What do we need to do here? Remember our final goal is to get this. So we got to get
separate the 10?
Everything. What's first step?
Would you move the 10 over?
Okay. This is 10.5. So if I move the 10 over, this becomes 1/2. Okay. Now what?
Now you have to get rid of the exponent, right?
Not quite. You want to get rid of that 4. That 4 is not being acted on by that exponent. That exponent only acts on what is below it. I would have to put parentheses around that whole thing if I was going to do the exponent next. How about we get rid of the 4 next?
So you just divide both by 4?
Huh?
And then you have b to the -3/4, or the power of -3/4, and then what, 1/8?
Yeah, so look at it now.
I'm not sure.
Well, it's hard to work with negative exponents, so let's change this to this. Okay? Now what can I say? Numerators are the same, therefore the denominators have to be the same. So b to the +3/4 has to equal 8.
Okay.
Now what? That's not one I can do without a calculator. I cannot take the 4th root of 8. At least, and not have it be a whole number. I could cube 8 and then try to take the 4th root of that answer, but let's just say we can use a calculator here. How do I turn this thing into b? What do I got to do to both?
I'm not sure.
Well, if I exponentiate both sides to the reciprocal of that, then I'm left with b.
So b equals 8 to the power of 4/3?
Well, now I can take the cube root of 8. What's the cube root of 8? What's the cube root of
8? 2.
It's 2, and then 2 to the 4th is 16. So this step here is a key step. You have to make sure that in order to get b, you basically have to exponentiate it to its reciprocal. If you think about that, if I had b to the 1/2 equals 4, how would I solve for b? I would square everything.
So you have b's 2.
That would leave b equals 16. Yeah. So no matter what that exponential exponent is, you can always get rid of it by exponentiating to the reciprocal.
Okay.
Let's have a look at that other one here. Whoops. Not there. Let's see, what is that? Minus x to the 3/2 equals minus 27. Minus x to the 3/2 equal minus 27. Okay.
Could you just flip the sides that they're on so they're both positive?
Yeah, we can certainly divide both sides by -1. Now what?
You have to get rid of the 3/2, right?
And how do I do that?
Ooh, I don't remember.
How can I exponentiate it so that it ends up being 1? That exponent b is 1. Remember, I'm going to multiply. Whatever exponent I put right here, I'm going to multiply it by 3/2. So it has to be the reciprocal.
So it's 2/3?
Yeah. And that multiplies to 1. So I'm left with x over there. And then what's 27 to the 2/3?
So just 18.
No, it's the cube root of 27.
Oh, cube root of 27 is 9.
It's actually 3.
3, 6. Oh, no, never mind.
3 times 3 is 27. So then it's 3 squared.
So x is 9.
Now, that's all we have on that page. So
I sent you 3 more.
Okay.
In the most recent one.
The bottom one?
No, the top one.
Top one? Okay. The bottom one just had the rest of those problems. Which one? The one on the left or the one on the right? The
one on the left has 2 problems.
Oh.
And the one on the right is just 1 problem.
Well, the problem with the one on the left is it's rotated, and I can't rotate it, but I can read it. However, let's do these in order. 8's next. Did 6 and 7. So I can do this one right here. Again, our goal is to get m all by itself.
So would you move the 10 over?
All right, so that gives you minus 64 equals minus m minus 10 to the 3/2. Now what?
So is it just negative m plus 10?
No, let's not distribute that. Let's divide both sides by minus 1. That way we turn that one into a positive and we turn that into a positive. Okay. Now notice that the minus 10 that goes with the m is inside the parentheses. So the next step I have to do is to get rid of this 3/2. So what do?
So do you multiply the reciprocal?
You exponentiate
the
reciprocal. So both sides to the 2/3. Now, what is 64 to the 2/3?
I'm not sure.
Well, when they ask you about cube roots of big numbers, you know your answer is either 2, 3, 4, or 5. They don't ask you otherwise.
So I think it'd be 4 then.
Right. So cube root of 64 is 4. Then you have to square it. So 16 ends up over there. And what's left over here is merely m minus 10. In other words, these two went away.
Oh, so I guess it wouldn't change the sign when you divided it.
Well, it would have worked. It would just made it more complicated. So now we move that 10 over and we get our answer.
So 26 is m? Okay.
So the steps you do is kind of dependent on what's inside the parentheses. In other words, when I got to this step right there, I could not get rid of the 10. The only thing I could do was get rid of that 3/2 exponent. But once I got rid of that exponent, now I can get rid of the 10. Now, this one, let me, this might just be the best way to do it right here. All right, so what is that? That is, all of these are going to be pretty much the same. It looks like. So what do we got? We got 9 plus.
Do you have the 10 problem 10 as well, or just 9?
I do. No, I've got 10 as well.
Okay.
Cube root of 2m equals 29. First step?
Would be the, ooh, I don't know actually. Get the m by itself. So I'll subtract the 9.
Okay.
And then do you divide by 5?
Now, if I wanted, I could write this like this. Might make it a little easier to see what the next step has to be.
Okay. So now do you do the reciprocal thingy?
Which is what?
2m to the power of 1/3 to the power of 3/1. So just the power of 3. And you do 4 to the power of 3.
All right. So that these cross off, and it leaves me with 2m equals 4 cubed, which is 64. M equals 32. Oops. Do this first. Three, 6, 4, 6 equals 1 plus 5 times 4 r plus 17 all to the 3/2 power. First step?
Okay, so I guess you could start off by moving the 1.
Okay.
And then divide by 5.
Okay, that's 7, 2, 9. Okay. Let's see, 5 goes in 7 times, 14. That's twice, remaining 4, 45 goes in 9 times. Okay.
And now you do the reciprocal thingy again.
Tell me exactly what to do.
So you do 729 to the power of 2/3. And then you put the 4r plus 17 to the power of 3/2 to the power of 2/3.
Okay. So 729. What do you suppose the cube root of that must be?
Would it be, I don't know, something like a 3 because it has a 9?
Well, it's not 3. 3 cubed is
It can't be 3.
27.
It has to be a,
That's got to be a bigger number.
yeah.
Notice it can't be, because 8 times 8 ends in 4, and then 8 times 4 ends in 2. We got to end in 9.
Mm-hmm.
Well, how about 9 times 9 is 81. And then when I multiply that by 9, I still have a 9 as the last digit. Bingo.
So it's 9?
So it's 9 is the cube root, but then you got to square it, right? In other words, you do the root first, and then you do the numerator. So it's 9 squared, so it's 81. That's what 729 to the 2/3 is. This is always whatever's in the inside. And now it's a relatively straightforward equation to solve. Okay, what else you got?
Let me send you one.
Okay.
All right, it's sent.
Is it this one or is this the old one you had sent me?
It's not that one.
Okay. Must be this one. If I can download that. Now if I can download it,
Oh, that's sideways. I can send you a vertical picture.
If I can download it, then problem is it doesn't know how to look at that JPEG file. Let's look at it like that as a photo.
I think looking at it as a photo should work.
See what it does. Yeah. Now I should be able to rotate it. Yeah.
Should.
Yeah, it will. It just takes a while.
Ah, okay.
All right.
So the ones in blue, I just wrote the problems up there, so it'd be
Yeah, I
easier.
got it. I got it. Okay, you see the four functions?
Mm-hmm.
Tell me what f of 2 is.
F of what? 2?
What do you, how do you do it? Just tell me how you would do it.
Oh, just take 2 of whatever F is, right?
You put it in wherever you see x.
The X, yeah.
Okay? What is f of 17?
You should replace the X with 17.
Okay? Most of these are composites. That's a composite, that's a composite, that's a composite. This is the only one that is not. That is straight multiplication. Okay?
Mm-hmm.
So it's g of x, which is x plus 2, times h of x, which is this. How do you multiply those two?
Just multiply the X into the negative 2x squared, 3x, and
Yes,
negative 1.
every term by every term. So start from the left, work your way right. Tell me what to write.
So it's negative 2x cubed plus 3x squared minus x. And then minus 4x squared plus 6x minus 2.
Okay? And the only thing we have to do is combine everything. Now the one thing, whenever you do one of these multiplications, you will only find one x cubed term and you will only find one constant. So it's everything in the middle that has to be combined. Not necessarily into one term, but I've got a couple of x squareds there and I got a couple of x's there. So what's my final answer?
Negative 2x cubed minus x squared plus 5x minus 2.
Uh-huh. Yeah, so you're good with multiplying. Now let's take a composite. So this one wants f of g of x. Okay? So what you want to do is start in the middle. You want to always start there. So what does this really mean? It really means f of what?
You just put g of 2 or x plus 2.
Exactly.
X is.
Now we're back to my first step. In other words, there's the f function. I've got an f of x plus 2. What do I do with what's inside the parentheses?
What did you say? I'm sorry.
Substitute it for x. In other words, the rule never changes. You take what is inside that parentheses and you substitute it wherever you see x in the f function. So what is that? Let's write it out. Let's not do all the math in your head. Let's just do it step by step. No, don't do any math in your head. I want to make sure you don't make a mistake.
3 and then parentheses x plus 2.
Perfect.
Plus, and then the end of the parentheses, and then it's plus 2.
That's why I think you should always do it this way. And what goes in the bottom?
X plus 2 in parentheses, and then it's minus 5.
Yeah, and it turns out I don't need those parentheses in the bottom. Now you can multiply it out.
Why don't you need the parentheses?
Why do you not need them? No difference.
Just because the... No?
In other words, the first step would be to remove the parentheses. I can remove them without changing anything.
Oh, because it's not multiplying there.
Exactly. So the top becomes 3x plus 6 plus 2, which is 3x plus 8. And the bottom becomes x minus 3. And that's our final answer. We cannot simplify that at all. Okay, so the clue on these composite functions is always start from the inside. So, what is this really? It's h of what?
The square root. I can't see it. Okay, never mind. It's the square root of x squared minus 4.
Minus 4?
Mm-hmm.
So that's what I'm going to write in there.
It's the square root of all of that.
Okay. So, how do I figure out what h of square root of x squared minus 4 is?
You just plug the
go to
square
the
root of x squared minus 4 into the...
And in other words, you always go to the outside function after you've gone to the inside function. And so tell me what to write exactly.
Negative 2 and then parentheses the square root of x squared minus 4 and into the parentheses squared plus 3 in parentheses the square root of x squared minus 4 and into the parentheses minus 1.
I think you got this. And I think you understand it. Okay, now simplify.
Well, because it's there's the squared for the square root of x squared minus 4 with the negative 2. Could you just get rid of all of the...
Not the negative 2. The negative 2 is not...
Or not the negative 2, but inside the parentheses.
Get rid of all of that. Okay. Now if I distribute that, that becomes minus 2x squared plus 8 plus 3 times square root of x squared minus 4 minus 1. Whoops, I can combine the minus 1 with the plus 8 and get plus 7. So if I'm going to, yeah, that's a fine way to write it. I mean, if I was going to write it, nah, there's no rule. It says that's not actually a polynomial. Because it's got one of the variables to the 1/2 power, which makes it not a polynomial, which means I'm not sure you really have to follow the rules. In other words, you don't have to put the x squared term there and the next x term in the middle. You could take that plus 7 and put it at the end.
So do we just leave the 3 times the square root of x squared minus 4?
I cannot distribute that 3. There's no way to distribute that 3.
Okay.
Okay. And finally, let's look at the last one, which is f of what?
R.
No. Tell me what to write inside the parentheses. In other words, the That's what they want, but my first step needs to say what? F of what?
3 over 2x minus 1.
Uh-huh. And now let's go to the f function. What's next?
You plug it in.
Read it to me.
In the parentheses, 3 over 2x minus 1.
Hold on.
And plus 2.
Hold on. First of all, I got that 3. Okay, so that's what I'm writing. And then in place of x, I got 3 over 2x minus 1. There's the plus 2. Now I got a denominator. And in place of that x, I'm going to write
3 over 2x minus 1.
All right.
Minus 5.
5. And now I got to figure out how to simplify. Well, I can multiply that 3 by that 3, turning that into a 9. Now, what I'm going to do next, just see if you can follow it. Okay, hold on a second. Let me read this. Still there?
Yeah, I'm here.
Okay. Whenever I hear that tone, I think I've lost. Okay. Here what I have to do is I have to operate on the numerator first. And I want to find a common denominator. What's my common denominator going to be?
The 2x minus 1.
Okay, so here's what I'm going to do. There's the 9 over 2x minus 1. And then this, since I want its denominator to be 2x minus 1, I just put that in the numerator, and that's the same thing, correct? That's the same thing as just plus 2?
I guess, yeah.
That's the way to do it. Okay? So now I can operate, if I distribute that, that becomes 4x minus 2. Now I can operate on the numerator. So the numerator is now 9 minus 2, so it's 4x minus 7, plus 7, okay, all over 2x minus 1. That is my numerator. Now let's do the same thing to the denominator. We got 3 over 2x minus 1. What do I got to do with that 5?
You have minus 5, and then do you just do times 2x minus 1?
Yep, you do a 2x minus 1 times the 5, and you divide it by 2x minus 1. And as long as that is still equal to minus 5, you've done it correct. And the whole point was to merely get a common denominator. So this numerator, that's going to be minus 10x minus 5, which is going to be minus 10x. I got a minus 5, which becomes a plus 5, plus 3, that becomes plus 8. So that is this numerator right there. Minus 10x plus 8. And that's over 2x minus 1. And that is actually my denominator. And what I had in my numerator was 4x plus 7 over 2x minus 1. And here's a little secret. If you have a fraction over a fraction and both denominators are the same, just cross them out.
Oh, okay.
Giving you a final answer of 4x plus 7 over minus 10x plus 8. Not simplify that at all. Now, that little trick was no different than flipping the bottom and multiplying. Notice that's what you do. When you divide by fractions, you reciprocate the bottom and you multiply instead of dividing. So if I take this and I flip it, and the 2x minus 1's cancel one another. And I'm left with 4x plus 7 over minus 10x plus 8. This answer. Okay. Sam, you good to go? You seem to know these composites really well.
I'm getting there.
Get them? Okay. I am going to let you go. We're only doing a half hour, right?
Yeah.
Okay.
Thank you.
I will talk to you tomorrow. Bye-bye.